This video we are going to talk about some of the properties of Laplace transforms. So you need to remember all the standard results of Laplace transform before we are going to deal with the problems. The first property of Laplace transform is L of t to the power n into f of t. That is, we have some function f of t and I have some t to the power n. Then we have minus 1 whole power n d to the power n divided by ds to the power n times L of f of t. In particular, if I put n equal to 1 in the above formula, this would become L of t into f of t is equal to minus d by ds of L of f of t. That means if the function times t, I have to differentiate one time with respect to s. Suppose if I have n equal to 2, you have to differentiate 2 times and so on. First problem, find Laplace transform of t into sin at. So this is like L of t into f of t model. So here in place of f of t we have sin at. By applying this formula I will get minus d by ds L of f of t. Here f of t equal to sin at. So I will write L of sin at. Next step, we will write the formula of sin at. We know that sin at equal to a by s squared plus a squared. Now I have to differentiate this with respect to s. So we remember the formula for quotient rule, u over v, it's going to be v du minus u dv divided by v power 2. Okay, so here in place of u I have a, in place of v I have s squared plus a squared. So by applying the quotient rule formula, we will get this will be minus s power 2 plus a power 2. Then if I differentiate a with respect to x, it will be 0 minus a, and by differentiating this will become 2s divided by s power 2 plus a power 2 the whole square. By simplifying this, we will get this result, because this is going to be 0 minus and minus plus, and this will be 2as. Same way we can do question number 2. So question number 2, we are asking to calculate Laplace transform of t into cosine 2t. So here f of t is equal to cosine at. So cosine at will become s by s squared plus a squared. Once again apply u by v method, we will get the answer as s power 2 minus a power 2 divided by s squared plus a squared the whole square. Question number 3, we have Laplace transform of e to the power minus 2t. So for this kind of problems, we have to apply shifting property of Laplace transform. So what is shifting property? If I have L of e power at times some function f of t, then what I do, first I apply Laplace for this function. So the answer will be f of s. Then in the answer we have to replace s by s minus a. Since we have a, we have to replace s by s minus a. Suppose I have e power minus at times f of t. So same idea, first apply Laplace for the function f of t. This is going to be f of s. Then in the resulting answer, change s by s plus a. So if it is a, replace s by s minus a. If it is e power minus a, replace s by s plus a. So here this problem we have given Laplace transform of In this problem, you can apply previous method or you can apply this shifting method. If you apply shifting method, this is going to be e power minus 2t times t. So here we will take Laplace transform of this. Then in the resulting answer, I have to replace s by s plus 2. We know that L of t equal to 1 by s power 2. Then I have to change s by s plus 2. So we will get 1 by s plus 2 the whole square. Question number 4, Laplace transform of e power minus 7t into sine 3t. So let us take Laplace transform of sine 3t. Then I have to change s by s minus 7 because we have 7 here. We know that L of sine 3t is going to be 3 by s squared plus a squared, which is 9. Then I have to change s by s minus 7. So this will be 3 by s minus 7 the whole squared plus 9. Another two more examples in this. So here the function is cosine h3t. So I will write L of cos h4t. Then we'll replace s by s minus 4. We know that L of cosine h4t is going to be s by s squared minus 16. Then I should replace s by s minus 4. So for this s we will change s minus 4. For this s we will change s minus 4 the whole squared minus 16. So this is the final answer. Question number 6, we have t e power minus t and sine 2t. So here we have t as well as we have e power minus t. So let us write the problem as Laplace transform of t into sine 2t. Then I should replace s by s plus 1. But now the problem is like this. This is like t into f of t. So we know that t into f of t, I should write minus d by ds of L of f of t, that is L of sine 2t. Then in this result, I should replace s by s plus 1. So once again, first we replace L of sine 2t. It is nothing but 2 by s square plus 2 square. Then we have to differentiate this with respect to s. So apply the quotient rule, we will get this one. Then by simplifying this, I have this one. Remember, still we have to replace s by s minus 1. So this would become 4, and this s in the numerator replaced by s plus 1. This s in the denominator replaced by s plus 1 the whole squared plus 4, this all to the power 2. By multiplying this, we have 4s plus 4. Denominator, apply a plus b the whole squared for this, and if you simplify, you will get s squared plus 2s plus 5 the whole power 2. Let us move to the next property of Laplace. This is called Laplace transform property of integrals. So this is going to be like this. L of integral 0 to t f of t into dt is going to be 1 over s times f of s. So here we have given Laplace transform of integral 0 to t cosine t into dt. So in place of f of t, I have cosine t. So now apply the formula. This is going to be 1 by s capital f of s. What is f of s? F of s is nothing but Laplace transform of f of t. So here 1 over s Laplace transform of what is f of t? F of t is cosine t. So we know that cosine t is going to be s by s squared plus 1. By cancelling s and s, we will get 1 over s squared plus 1. Next property, Laplace transform properties of division by t. Sometimes you have the function in the numerator and there is a t in the denominator, or I can say the function divide by t. Then it's going to be s to infinity, only one integral, not two integrals, only one integral. Integral s to infinity L of f of t into ds. That means in step number 1, you have to write f of t. Step number 2, you have to take Laplace transform of f of t, and step number 3, you perform the integration with respect to s. So here in this question I have given L of sin t by t. So here f of t equal to sin t. So let us substitute in the formula. You have L of sin t into ds. So this is nothing but integral s to infinity. L of sin t is 1 by s squared plus 1 into ds. This is nothing but tan inverse of s. We have already discussed many problems in this. So integration of this one with respect to s is going to be tan inverse of s between s to infinity. First substitute the upper limit infinity, then minus replace the lower limit by s. So you are replacing s by s, so there is no change. You will get tan inverse of s. We know that tan inverse of infinity is equal to pi by 2. So we have pi by 2 minus tan inverse of s. And this is nothing but cot inverse of s. Question number 9, sin omega t divided by t. So by seeing the problem, we come to know that f of t equal to sin omega t. By substituting this in the formula, we have integral s to infinity L of sin omega t into ds. So sin omega t, I can write omega by s power 2 plus omega squared. Then take this omega outside, we have 1 by s power 2 omega squared. By integrating this with respect to s, this is going to be 1 over omega tan inverse of s over omega. Then cancel omega and omega, we have left with tan inverse of s by omega. By replacing upper limit infinity, we have tan inverse of infinity. By replacing the lower limit s, we have tan inverse of s over omega. So this is going to be pi by 2 minus tan inverse of s over omega, or I can say this is equal to cot inverse of s by omega. Next question, L of cosine 2t minus cosine 3t divided by t. So here f of t is in the numerator. So we will write in the formula. Then distribute Laplace for the two terms, cosine 2t, cosine 3t. So first term will become s by s square plus 4. Second term will become s by s square plus 9. Integration of s by s square plus 4 is going to be 1 by 2 ln s square plus 4. Integration of s by s square plus 9, it's going to be 1 by 2 ln s square plus 4. By using the log property, we know that log a minus log b is equal to log of a by b. I will get this one. Then from the numerator, take s power 2 outside. From the denominator, take s power 2 outside. We will get this one. Then by cancelling s power 2, I will get this. By substituting the upper limit infinity and lower limit s, we will get the final answer as 1 over 2 ln s squared plus 9 divided by s squared plus 4. In most of the problems, this kind of problems, you see this step. Okay, the answer is going to be the reverse. That is, you just take denominator into numerator and numerator into denominator. Only these kind of problems, the answer will be always like this. See you in the next video.